Hello, everyone, and welcome to today's webinar, From Soup to Nuts, the Journey of a Sample Through an Automated Clinical Microbiology Lab. I am Kaylee Bach of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by BD. To learn more, please visit bd.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speaker, Marco Janssens, Head of the Laboratory Clinical Microbiology of the St. Elisabeth Hospital, Tilburg in the Netherlands. Marco, you may now begin your presentation.
Okay, thank you and welcome everybody. To be honest, it's a new experience for me to sit in front of a presentation screen, not seeing the audience, but we'll see how things go. So I will take you on our journey in let's say, becoming a more efficient lab, and as you can see in the title, where we try to keep all the samples on the move. And first, I like to kick off with a few old data. And as you can see, many years ago, our lab processed about 50,000 samples. And for that, we had a 33.5 FTE on formation. If we look at today, we process about 75,000 samples and only with 15.3 FTE. So you can see that we increased the number of samples with 50% and we decreased the number of staff with more than 50%. If you look at those numbers, the only conclusion for me is we have to have become more efficient. And becoming more efficient started, in fact, for us in the year 2006, where we came in contact with the principles of lean. And probably you all know about lean. The two major objects in lean is try to eliminate waste in your process and create flow. And in 2006, if we speak about waste, at that time only 7 types of waste were let's say available. Nowadays, fortunately, there is one more, and I think that's the main thing or the most important thing, the brain of you all. So now we have 8 types of waste. If you don't use the brain, well, then you have a big problem. So we learned a lot about lean and try to look at all these types of waste. And at a certain time, we came to the point, okay, what can we do to make our life easier? And I will not bother you with all the things that we did on the lab since that time, but I can tell you that, well, it goes into hundreds of improvements that we did to, let's say, to make our life easier and to get our process in better shape. Doing that, we still got a lot of waste left over. And in microbiology, plate handling is one of the major things in forms of waste. And as staff, lab staff, we like to walk around. There are a lot of movements going around on the lab. And I have a slide for you where we videotaped one technician, only the feet, of course, and we followed that technician for 22 minutes. And as you can see, that person has walked 354 meters. So, in fact, we were very good employees. So you get paid to get physically fit. But of course, it takes a lot of time and a lot of waste in this case. Then we came to a point that we already did a lot of improvements, but we tried to move the organization towards lab automation for two major reasons. First of all, the improvement of quality. You try to have a full traceable process, and a very important thing in processes is standardization. And the other thing why we want to move towards lab automation is efficiency. Would it be possible to handle a plate only when it's necessary when it needs work? Then we came to the implementation of our total lab automation, and that started already in 2006, in the same year that we came in contact with the lean principle. We also came in contact with the company Kiestra at that time. We discussed with them the possibilities of total lab automation, and Kiestra did a quick scan of the lab. And one of the things that came out of the quick scan, that our lab had an LPI of 14.4, and LPI stands for the number of samples per FTE per day. So there was this number, and at that point for me, that number had no meaning at all. I had no clue if this was good, bad, or average. So, okay, the number was there. So as you can see, it took us quite a while to sign the contract. That was done in 2009. Then in January 2010, Kiestra started building up the instrument. And in February 2010, we started training our technicians. And then halfway of March, we could start with the implementation. And there we had a little disagreement with Kiestra at that time. Kiestra had at that time the vision, if you start with one or two easy sample categories and you process them for 4 to 8 weeks, if that goes well, go on to the next two sample categories, etc. If you do it like this, implementation would take several months. We already learned a lot about lean, and we knew that when we started with lab automation, we had to make a lot of settings in the system. So then came our vision, hey, you know, if you make settings yourself, you make mistakes. So our idea was, if we start with 5 samples per sample category per day, and we process them for 1 week, then there is a reasonable chance that all the mistakes that we made are, well, let's say, discovered after 1 week. If that is the case, we could go on and double our process with 10 samples per sample category per day and do that for 2 weeks. So this is how we did our implementation. And the outcome was that we started on March the 14th, and we had a full implementation, and it's not a joke, on April the 1st of 2010. So it took us only 2.5 weeks for a full implementation of our lab automation. And of course, you come to the question, what is the best way then? To be honest, I don't have the answer, and probably the answer is somewhere in between, in the middle. And this is the system where we started with in 2010, and it even had a very nice name. It's the sample that moves. And as you can see, we started with only one first-generation incubator, 8 workbenches, and a part where the plates are stored. So what was at that time the impact on our process? Okay, we didn't have to label the dishes anymore manually, and in that time it was this number, 3,500 to 5,000 dishes per week. But the major thing was that we didn't have to handle all the plates anymore. And if you look at this number closely, you see that only 20% of all the plates that we put in the system were used for, let's say, culture proceedings. So we have an 80% reduction of plate handling. And if you would do on your own lab, let's say, just measurements of how much time is spent on plate handling, then you will realize that 80% reduction is a huge amount of time. Of course, we didn't have to walk around as much as we did, because the plates went automatically to the incubator and from the incubator to the workbench. Only our plates that were not incubated in the system, okay, we have to pick them out of the incubator, put them on the track, and then get a picture. And for the patient, of course, our results were earlier available, but because from 2010 till today, the average reading time is still between 30 and 40 seconds per sample. So for instance, an easy MRSA culture might take me 1 or 2 seconds to read, and a difficult pus, perhaps a minute and a half. But on average, it has been for 12 and a half years now between 30 and 40 seconds, which is pretty quick, I think. We come back to the LPI. Remember that we started in 2006 with an LPI of 14.4. We start installing lab automation, and as you can see, working 2 years with lab automation, we increased the LPI, the productivity, with more than 90%, which is, well, almost doubled. Even to become better, there were developments during these first years that we worked with lab automation. So at a certain time, a second generation incubators was built. So we invested in 2 new second generation incubators, and we invested in inocula, an automated inoculation machine, so nobody has to do the inoculation manually anymore. And another advantage with this type of inoculation is, you see it on the left top of the screen. You see a picture of a plate, and I think each lab has sometimes these examples. Somebody tried to imitate the Zorro signature, I think. It means you have a culture with where you can do nothing with. You have to redo it the next day. Using the machine, it's always the same streaking pattern with always the same high quality result and single colonies to work with. Doing that should have an effect also on the LPI. And as you can see on the right side of the slide, you see that we installed the inocular and the 2, they are called Rita Compacts, in 2014, and again, an increase of LPI of 27%. We want to do, that's the next slide. Of course, a clinical impact. We think quality improved because you have a process that you can follow from the first to the last step, because everything is logged in your system. Another advantage of working like this is you can always have a review. If you are a manual lab and a technician decides to throw away the plates because that technician thinks we're done, okay, your evidence is gone. With lab automation, of course, you can throw away the plates physically, but no one can throw away the picture. So if necessary, you can always have a look back on how was it with this specific culture. And another important thing, because you have a decrease of turnaround time, a patient can be treated in an earlier stage. It wasn't enough for us, so we kept thinking about the future at that time, and I will show you a graph, and I try to explain it to you. The red line is the number of samples that is ready for reading at that time. And as you can see, we were a lab that worked only daytime. So you see, during the night, hundreds of samples are just waiting. And we also know that waiting is, well, one of the top forms of waste. The green line, that's the lab technicians. That's the line that says how many samples did you read. As you can see, we have a huge gap between the number of samples ready and waiting and when they are read. And in our opinion, the only thing to solve this problem is we have to go to a 24/7 schedule. And that is what we did at that time, and that was in 2014. Doing that must have effects on the entire process. And now I will show you a few different slides about different steps in the process and the effects of 24/7 compared to, let's say, a regular day schedule. As you can see, this is a graph that shows the workload in first inoculation, so setting up new samples. And as you can see, our day was filled with huge peaks. So if you would ask a technician, how are you doing? They were always busy. Looking at the same graph, but then in a 24/7 schedule, you see, of course, there are peaks. You will never get the ideal straight line, but you can see that the peaks are much lower than before. So if you would visit the lab at that time, you saw the people not being stressed. Of course, after inoculation, we have to start reading. And as you can see, when we entered the lab at 8, of course, we just saw hundreds of samples were ready for reading. So we started with an enormous peak in work of reading samples. And of course, during the day, a bit lower, but they were still there. We look at that in a 24/7 schedule. You can read all day, and each mark in the graph stands for a 15-minute timestamp. Well, if you have a high peak in the morning for reading, we know that a few hours later you have the enormous peak in doing follow-up work. And also, in a 24/7 schedule, almost every peak is well, almost gone. So if you combine all these graphs, you see that our days were filled with high peaks of workload. So yes, we were having the feeling that we were very, very busy and that it was always too much work for the group that has to work. And in the 24/7, you see, we can just go on doing work throughout the entire 24 hours. If we go back to the graph that I just showed you, and that's the one on the left corner, that was the one with the big gap and the waiting time. If you look to the right corner, you will see that the red and the green line are almost on top of each other, which in fact means if your sample is ready for reading, we read it. If you do it like this, it must have an effect on your turnaround time on your cultures. And these are just a few examples of different protocols that we had those days. And you see the enormous decrease in turnaround time of those different protocols. But we want more, because more is developed, so we want more. We want to improve more, become better, become more efficient. So at a certain time, the UCA, the Urine Culture app, was developed, which is a software application to sort out your negative urines from your presumptive positive ones, from which, as a final result, you could automatically send out your negative results. So that means that, for instance, your no-growth urines should not be seen anymore by any technicians. So that only leaves the urines with growth on it that needs attention from a lab technician. A few years ago, Identifa came into the lab. Identifa is the automated machine that prepares the MALDI target plates for you. And I will come back to this one later. A year before Identifa came, a new software platform was introduced, Synapses, and the last slides of this day will be a total focus on Synapses. And then, of course, applications for MRSA, VRE, CPE, ESBL, and the last thing, and that's the one that I would like to have, is an application for growth monitoring for sterile samples. Just to make sure that the most important samples that we have are monitored by a software application that will notify me if there is growth. Going back to Identifa, we installed it 3 years ago. So when we read plates will automatically go, and we need identification, they will automatically go to Identifa. Identifa will prepare a suspension, prepare the MALDI target plate, and then the only thing we have to do is put the MALDI target in the MALDI top itself. Another thing that the Identifa can do is, because it prepares a heavy suspension to prepare the MALDI target, but it can also dilute this heavy suspension back to a 0.5 McFarland suspension. The suspension is made in deionized water. And wouldn't it be nice if we could use the 0.5 McFarland suspension to set up the AST, the Phoenix panels? So right now, we are working on a validation on that subject. So as you can see in the slide, it starts with a plate with markings on it. It first goes to Identifa. In Identifa, it will get let's say the +4 McFarland suspension, from which the MALDI target is prepared and then measured in the MALDI top. From the heavy suspension, Identifa will dilute it back to a 0.5 McFarland. We inoculate the broth with that, set up a Phoenix panel, put it in the Phoenix, and then compare these results with the normal lab routine, which is on the bottom of the slide. The same plate will take the Identifa route, but also the next step is to go to the workbench. On the workbench, we prepare the suspension, put the suspension in the Phoenix AP to get the correct dilution, inoculate the Phoenix panel and put it in the Phoenix. We're about 3/4 now of the total that we want to test. And a few weeks ago, we already submitted an abstract on the preliminary results of these two methods. And okay, it's not final yet, but let's say it's looking very good. So we started in 2010 with this TLA. In 2014, we replaced the first generation incubator for two second generation incubator, and we installed the inocula. And nowadays, it's a system with an extra incubator just because we got more work, and the identifier connected to the track. My next series of slides is about Janssens, the new software platform, well, the software platform that was released about 4 years ago. We started as, well, we were the first in Europe to have it, and we started at the same time with 2 American labs. I will just take you through the different screens of Janssens, and hopefully I can give you a good impression of how it works, what it does for you. I was going to do it live, but the, how do you say it, the firewalls in the hospital does not allow to enter all these things. So I have to do it with slides. Opening Janssens, it always starts with a personalized dashboard. And as you can see, I have quite a lot on my dashboard. The graphs are more for my fun. On the left side, that's more, let's say, to give me a good view of where we are and how the process is going, and if I, as a lab manager, need to do anything about staff. Do I need extra staff on certain steps or not? It starts with a series of quick links just to go to different modes in Janssens. Underneath that, a small table with an overview that says ready for reading schedule, which is nothing more than an overview that tells you how many samples are ready for reading at this time and how many samples will become ready in the next few hours. The one on the right side of the quick links is the workload status of the different types of follow-up work that we defined. It's all about how you define your work. Well, we defined several types of culture workup. And as you can see in this table, per type of skill of workup, the number of plates that are, well, that needs to be processed by that specific lab technician. And finally, I have an overview of the number of ID results are available for review. If we use identifier for identification, all the results are sent to Janssens to get a review, so you can send them after review to your LIS and, well, confirmatory result over there. If we go to the first step in Janssens, which is culture inoculation, we come to a screen that we use the least, because this is a screen that is used for samples that you inoculate completely manually. And as I already explained, we have an inocula. An inocula has a full automatic side and a semi-automatic side. So for us, it means we put as much as possible in the full automatic sides and the samples that cannot be processed by the FAA side, we process them semi-automatic. So only the samples that cannot be processed by the inocula, and well, you can think, for instance, on the tip of a catheter. You need to roll it over a plate, so that cannot be done by the inocula. That is done in this mode. So I think for me, on my lab, perhaps 3 samples per day in this mode. When you have the sample and you scan your sample ID, the information from the LIS is sent to Synapses, and now you can see, okay, you need to inoculate these different plates or tubes, whatever it takes. You request the plate, you inoculate the plate, and then tell, okay, I'm done. And from that point, all your media will get the status that they are inoculated. If we go to the second quick link, which is culture reading, you see in my case, you see quite a lot of different work lists. And a work list is nothing more than a list of samples with all the, how do you say that? Well, no, the criteria for a list are made by you. So in my case, most of the lists, well, all the lists are based on sample type. But if, for instance, on your lab, you want to have a special list for ICU specimens, as long as your LIS can send that information to Synapses, you can use it to create your own work list for that. So we have the different categories, and there is always, I'm afraid it's in Dutch, there is always one work list that says all cultures ready for reading. Because you can imagine in the beginning of the day, you start working based on, okay, I start with urines, then I go to that. But later on, when you only have a few samples in each folder or in each work list, you switch to the all list and then work them one by one. So what I did in the work list culture reading, I just opened a urine culture, and as you can see in the screen, and I blurred it out because it will provide you with some patient demographics on the left side, and on above that with the barcode on it, it's the sample number. And in this case, we have a urine culture with 2 plates. And I choose a urine as an example because you can also see what the urine culture app does for us. On the right-hand corner of each picture, you see some text. One of them, the top line, is GS, stands for growth score. So the software application will give me a growth score of this specific plate. The second thing that the software application does for you, it will give you, let's say, a purity comment, I would say. So in the software, there are 3 possibilities to get your purity comment, which is like here, it's pure, and pure means in the software more than 99% of all the growth on the plate is one type. The second thing the software can tell you that it's predominant, and predominant is between 90 and 99% one type. And if it's not pure or predominant, it will be called complex. And then we have a third thing on the screen of the chromogenic media. There's this sort of microorganism, and if you hover over it with the mouse, you can see on the screen, it will give me a presumptive ID. So in this case, it's an E. coli, but the software can also give you the PMP group, which stands for Proteus morganella or providentia, KES group, which stands for Klebsiella enterobacter serratia group. It can tell you if a Staph saprophyticus is in it, a strep B is in it, Enterococcus species, and if it's not one of those 6, it will tell you it's other. We go on to the next, because the next step is, okay, I want to do something with this culture. And as you can see, I marked 5 colonies, and it's always, when you use identify, you always mark several colonies, 3 to 5 colonies depending on the size, because identify wants to create a heavy suspension. You can imagine that with a small colony, 1 colony is not enough to create a heavy suspension. So you mark 3 to 5 of the same colonies, and then on the right side, the only thing you have to do is under the header organism name, we fill in a sort of presumptive ID. So in my case, I just filled in, it looks like a gram-negative. And at the quantity spot, you fill in the quantity. And if the quantity is measured by the urine culture app, it will be filled in automatically. Just by choosing my presumptive ID, it looks like a gram-negative. On the lower side, on the right side, I will get different protocols to choose from. Well, my standard protocol is always combined with an automated MALDI. So I've chosen the standard protocol, and a bit above you can see by the order test, okay, I requested a purity plate because I also want to set up an AST, and I ordered an automated MALDI. So when I've done that, I would press the button mark as read, and then from that moment on, this marked plate will get the signal, okay, now you can go to identify. So without manual request by anyone, the plate will be sent to identify to get his MALDI. And the software will go on to the next sample that is ready for reading. Looking at this, because I told you with the urine culture app that it separates the negatives from the presumptive positives. Well, in this case, my negatives are still being put in a sort of work list for me to check. So I don't send out negative results automatically yet, but that's to come. So in this case, as you can see in my proactive auto verification list, there are 2 samples for me to verify that the application was right. So just by pressing it, I will come into this screen and I just look at, okay, I see negative plates. Also, the gross score is less than 100 CFU per mil. So the only thing I have to do now is on the right side on the screen is press the button accept, and then my code for a negative result is sent to my LIS and sent automatically to the physician. The third mode in Synapses is about culture workup. And culture workup is nothing more than I showed you the table with the different types of workup. Well, the technician that is responsible for specific workup can see in its screen, okay, there are plates for me to be processed. The technician requests plates to the workbench. When the plate arrives at the workbench, you just scan the barcode on the side of the plate, and then you will get the picture of that specific plate. And that is the biggest difference in screen between a workup screen and a reading screen. In a reading screen, everybody sees all the plates of that sample. In a workup screen, you only see the picture of the plate that needs workup. And if you look closely at the picture, you see 5 markings on it, of which 3 are marked black. The black marked colonies, that means that the inocula only used 3 of the 5 marked colonies to create the heavy suspension. Identify will pick a few colonies, create the suspension, measure the suspension. If it's high enough, it will stop picking. If it's not high enough, it will continue to use the other colonies that you marked. So in this case, we scan the barcode, we get the picture, and on the right side, I can see what type of work do I have to do. After doing it, the technician presses the button, okay, I've done it. And again, everything will be logged, so you know exactly which technician has done what at what time. Then finally, if we have the MALDI, you still want to check, okay, before you're not sending out automatically all the results. So there is this ID AST review list. Opening that quick link, you also see different work lists, one with the all isolate, ready for review, needs attention. Well, the needs attention might be the ones that has a score which is not high enough. So we just open the list, and this is what you see then. Again, the patient demographics on the left side with, of course, the sample number, and we see, let's say, the top 10 of this specific strain. What you also see, and that's a bit above the table of the top 10, you see the turbidity that was measured by Identify. So if we agree with this result and we want to send it to the LIS, use the button mark as reviewed and send to LIS. Just by pressing that, it will send the result to the LIS, and the next isolate to be checked will be presented in your screen. And now I hope that I gave you a good impression of what we have, what we do, and what we are trying to do in the future. So I think we're there.
Great. Well, thank you, Marco, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. So let's get started. Our first question asks, what part of automation do you think is enabling you to achieve faster turnaround times?
I think if I look at the last 12 years, then I think all parts are, well, perhaps not all necessary, but if you really look at all the different parts, then I would say that all parts are more or less even valuable to achieve this. So what I mean is the fast incubators, the automatic inoculation, of course, of the samples, the identifier that is doing its work while you are doing some other work. So yes, I think all the parts are equally valuable for this.
Great, thank you. Another question we have here. What is the value of Identifa for your lab?
Identify makes sure that first of all, I have a continuous process. Like I said, when people are reading, Identify is doing the work while other people are reading, and it's a very standardized method, and I don't have exact data in how much better Identify creates moldy targets compared to manual, but I just know that, let's say, the number of green moldy spots, moldy results from Identify compared to the manual ones is Identify is much higher.
Great. And I want to thank our audience for these great questions they're submitting here. We'll go ahead and continue with this next question. This asks, what are the qualitative non-measurable benefits of Identifa?
Non-measurable. Like I said, the number or the percentage of moldies that gives a very good result, a high result, is much higher than with the manual method. And to be honest, we never measured when we didn't have Identify. We never measured how many moldies do we have to redo because, well, someone perhaps did a good job. So exact numbers are not available, but the feeling and just seeing it, we just know that it's a much higher quality.
Great. Now, Marco, what is your staff's opinion about Identifa, and how is Identifa adding value to their day-to-day work in the lab?
Well, that's more or less the same answer. It's also for the staff that they see that it's a continuous process, and they are already used to focus on what can we do to improve our processes. So for them, Identify fits very well in the mindset of becoming more efficient and getting better results, because it's a combination of both. And of course they see it, they feel it, they realize that not a lot of moldies have to be done again by someone else. So it's for them, it's a sort of it really fits the way we were used to think and the way we used to work.
Great. We have another question to this regard. How did the older staff take to the new way of reading cultures?
Yeah, that's a good one. It was a let's say a hard way of learning, and not only the older ones, but I understand the question. Of course, it's not easy for someone that has been doing reading, let's say manually, for 25 years, and then have to trust a picture. So what we did is first of all tell everybody, if you don't trust the picture, just press the button and the plate will be brought to your workbench. Because it's not me that can convince the staff. The only person that can convince you is yourself. So when we started, I think well, let's say 25 to 50 plates per day were requested to a workbench by technicians just to make sure that what they saw on a screen was reality. If I think nowadays, I don't even know if we come to a count of 5 for that purpose. So it's more a matter of trying to get everybody to feel comfortable with it. And when we started, we also said, okay, just give it a year. It wouldn't be fair to try, let's say, within a month, everybody to feel comfortable. We thought that wouldn't be fair. So we just took a year, and yeah, after a year, I could say, okay, now I'm sure that everybody in its own way, because it's still technique. And again, not everybody has the same feeling with technique. So that's also a thing that comes along with it. But now everybody can work very good with it. So there is no thing that holds people back, because they know, if I don't trust it, okay, I just request the plate. Within a minute, it's on your workbench.
Great, thank you, Marco. We have time for a few more questions here. This next is a two-part question, and it asks, do you process positive blood cultures in Kiestra? And how do you transfer samples from the bottle to place in Kiestra?
Yes, we process them on the system, and what we do is we have these venting units. So we put a venting unit through the cap of the blood bottle, and we process those bottles on the semi-automated part. So we scan the bottle, plates are being brought just in front of you. We put a drop of blood on each plate. They are streaked by the inocula, and then they are they go to the incubators.
Great. This next question asks, what advice would you provide for labs considering automation?
I think let's say, for me, the most important thing is, if you switch from manual to lab automation, forget what you did manual and create a complete new process with the knowledge that you have, what you can do with lab automation. I am convinced that if people invest a lot of money in lab automation and you put your manual way in the lab automation, it's not going to be a success.
Great. And that answer was a great segue to our next question here. Before the introduction of automatic reading, was there a comparative measurement of the efficiency of manual reading and automatic reading?
To be honest, no, because it was, for us, let's say, being focused on efficiency and introducing lab automation came more or less at the same time. So when we came in contact with the lean principles in 2006, for us, that was the moment to become really focused on, okay, we are doing our work for so many years in a certain way, and nobody thought about it. Can we do it better or whatever? Unless we were triggered by, this phenomenon that focus on your process and be honest to your own process, that perhaps some steps can be improved. You don't have to be ashamed about it. It's more a matter of, am I willing to see that some steps that I make can be done better or more efficient.
Great. And it looks like we have time for one more question here, so we'll go ahead and wrap up with this one. Has there been improvement in patient discharge time or ICU time because of faster turnaround time of results?
Yeah, that's also a hard one. And again, to be honest, I once spoke with one of the, I believe, the Canadian ladies of BD, and we discussed, okay, would it be possible to get all these measurements in to answer this question? And to be honest, it is so difficult to really focus on, okay, what happens if I send out my final result half a day earlier? Is the discharge pure based on my earlier result, or is it a combination of my earlier result combined with perhaps some other things? So we never dug into it because it's really so much work to figure it out. But again, my heart says yes, it must have an effect on discharge. I think there is no other way.
Great. And Marco, we're going to squeeze one more question in here. This last question asks, was there a reduction in the number of staff as a result of the automation of work processes?
That's a yes and that's a no. If the question means, did you fire anyone when you introduced lab automation, the answer is no. But when we knew that we were going into lab automation and we learned a lot about lean, we already optimized so many processes that each time, for instance, a lab technician wanted to go work part-time or a lab technician left the lab, that we didn't fill in those empty spots because it wasn't necessary anymore. So my more than 50% decrease, what I showed in one of the first slides of staff, is pure based on, let's say, natural, how you say that in English, natural causes, or it was a natural process, and no one was fired because of this.
Great. Well, that brings us to the end of our session. So thank you again, Marco, for your time today and your important research. We would also like to thank LabRoots and our sponsor, BD, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.